Hey everyone, what's up? This question was taken online from a practice exam. No calculators are allowed. Let's get started. The question is, if the letters Q, U, E, E, N were arranged in all possible ways to form all possible words, and then all of the resulting words were listed in alphabetical order, regardless of whether or not they are actual words, at which position in the list would the word queen, that is Queen, be at? Pause the video, give this question a shot, and when you think you know the answer, come back to it. My hint is, before you start solving the problem, find out the number of possible words that the letters Queen can form at most. So the number of permutations. And this question, unlike the others on my YouTube channel, does require knowing how to work with permutations. Anyways, let's get started. As I mentioned, I'm going to start by finding the total number of permutations these 5 letters can form. And as you can see, we have one letter, specifically the letter E, that appears twice. So Queen, where I'll call the left E1 and the right E2, is actually the same exact word as QU, E2, E1N. It doesn't matter which order the E's come in because they just represent one word, so this will be counted as exactly one word. But before we worry about that too much, let's just think about how to calculate the total number of permutations. There are a total of 5 letters, so the words we end up with all have to be 5-lettered. For the first letter, we have 5 options. It can be Q, U, this first E, this second E, or N. So we have 5 options for that. For the second letter now, we only have 4 options remaining, since one of the letters was used for this first spot, so we have 4 letters remaining. Then for this third spot, we have 3 letters remaining. For the fourth spot, we have 2 letters remaining. And then whichever letter is left over, that must be the last spot, so there's only going to be one option. In all, there are 5 times 4 times 3 times 2 times 1, which is equal to 5 factorial permutations. But this is without taking into account the repeated letter we have here. We must realize that anytime we have a permutation, for instance, if we have this word over here, Nequeu, there are going to be 2 permutations that both represent this word. The first is going to be Nequeu, where E1 comes before E2, and the second is going to be where E2 comes before E1. So in the answer we got over here, the 5 factorial answer, what we did is we double counted every permutation, because when we should have only one word, we actually counted 2. One where E1 was before E2 and the other where E2 was before E1. So to get the correct number of permutations, we simply have to divide 5 factorial by 2 factorial. And 2 factorial is just 2. The total number of permutations is 60. Now, if you're wondering why we divided 5 factorial by 2 factorial, it's because if you think about all the repeated letters, which is just E1 and E2, for the first position of E, we have 2 options, whether it's E1 or E2. And for the remaining position of E, we have 1 option left, whichever E wasn't used. Now, let's just say if we had 3 E's, we would have divided 5 factorial by 3 factorial, because then you have 3 positions where E is used, and the first position, you have 3 options for the E, second, 2 positions for the E, and so on. In that case, you would actually be counting the same permutation 6 different times, because 3 factorial equals 6. Now anyways, going back to the question, we end up with a total number of 60 permutations. At the least, queen can be the first position in the list, and at the most, queen can be at the 60th position in the list. First, let's just put the four letters Q, U, E, and N in alphabetical order. So we get E, N, Q, U. All of the words beginning with the letter E will go first, followed by all the words starting with N, and then all the words starting with Q. And somewhere here we'll have the word Q, U, E, E, N, and then followed by all the words starting with U. E will contain the first word, and so on, and then we just have to figure out where queen would be. But since queen is probably going to be towards the bottom of the list, I'm going to start from the bottom. So I'm going to first calculate how many words start with the letter U. So if we note that the first letter has to be U, the next four letters can be E, E, N, or Q. The number of permutations for these next four letters is simply equal to 4 factorial divided by 2 factorial, once again, because we have 2 E's, which equals 12. The number of total words that start with U equals 12. The last 12 words out of the total 60 permutations would be the 49th word all the way till the 60th word. So within all of the words that start with Q, they could either start with Q, E, Q, N, or Q, U. Now this is also in alphabetical order. It's all within Q. Q, U, E, E, N. It clearly falls at the end, but we don't have to worry about these top permutations. Just worry about all of the permutations that begin with Q, U. If you know the word starts with Q, U, you have the letters E, E, N remaining. So the number of permutations that start with Q, U equals 3 factorial, since you have 3 letters, divided by 2 factorial, since 2 letters repeat, which equals 3. So only 3 words can be formed starting with Q, U. And those are these 3 words. And this is also in alphabetical order. So Q, U, N, E, E is the 48th position in the list because it is the highest in alphabetical order within all the words that start with Q. So that makes Q, U, E, N, E the 47th. And that makes queen, which we wanted, which is Q, U, E, E, N, at the 46th position in the list. Bye guys, see you in my next video.